Hi grade 12s and welcome back to the Opinionated Science Educator channel. As we continue the lesson on the factors affecting the rate of the chemical reaction, in this part of the lesson we will look at each of the 5 factors that affect the rate of a reaction. Okay, so this lesson is from the knowledge area Chemical and Change, and this is lesson 13, Rates of Chemical Reactions, Factors Affecting the Rate. From CAPS you should be able to do the following. Number 1, you should be able to define the rate of a chemical reaction. Number 2, list and describe how various factors affect the rate of a chemical reaction and explain at a particulate level how each of these factors affect the rate of the reaction. At the end of the introduction, I gave you 2 questions to answer. One was to define the rate of a chemical reaction, and the second was to list the factors that affect the rate of a reaction. So the answer to the first question, reaction rate is the speed at which the reaction proceeds. Now it is often defined as the change in concentration of products per unit time or the change of concentration of reactants per unit time. Now if you remember from the previous lesson, we looked at ways to measure this change. So it can be measured as an increase in the volume per unit time, or it can be measured as a change in mass per unit time, or the change in turbidity, or so on. So those are the answers. That is the answer to the first question. How do you define a rate or the rate of a chemical reaction? Now let's look at the second part, to listing the factors that affect the rate of the reaction. So firstly, the nature of the reactants will have an impact on how quickly or how slowly the reaction proceeds. So the first is the nature of the reactants. Secondly, the state of divisibility or division, which is the same as the surface area of a solid exposed to another reactant. Temperature is another factor that affects the rate of the reaction. Concentration, or in gases, this includes the pressure at which the gases are, because you change the volume, you will change the concentration of a gas, will affect the rate of a reaction, and the presence of a catalyst will affect the rate of the reaction. So those are the answers for the activity based on what was covered in the introduction. So I hope you got all of those correct. Let's see if we can just apply some of these principles just by intuition based on the chemistry you already know. So I'm going to start with the nature of reactants. Will the reaction rate between lithium or potassium with cold water be faster? If you remember your grade 10 work about reactivity, there's the periodic table, lithium, potassium, sodium. Going down, what you should remember is that the reactivity of the group 1 metals, the alkali earth metals, increases as you go down the group. Potassium is a lot more reactive than lithium. Okay, so we would expect the reaction rate between potassium and cold water to be faster than the reaction between lithium and cold water, purely based on the fact of the reactivity of the group 1 metals, which increases as you go down the group. Okay, let's now look at the second one. Will the reaction of fluorine gas or bromine with sodium be faster? So again, think about it. Think about what you learned in grade 10 and the reactivity of the halogens, because both fluorine and bromine are halogens. So let's just bring this in. There's the periodic table. You can see there's fluorine, there's chlorine, there's bromine. if you remember what you learned in grade 10, you should remember that the reactivity of the halogens increases as you go up the period. So in other words, fluorine is far more reactive than bromine. We would therefore expect the reaction with fluorine gas to happen at a faster rate than we would with bromine. Okay, so that is the nature of the reactants. The type of chemicals involved in the reactions, depending on their reactivity and so on, will have an influence on how fast or how quick or how slowly the reaction proceeds because of the nature of the substances involved. Okay, now let's look at temperature. If you have the Alka-Stelzer in hot water or cold water, in which one will it react more quickly? Well, let's actually have a look. You can see it is reacting a lot more quicker in the hot water than it is in the cold water. So as you saw there, it reacted a lot faster in the hot water than it did in the cold water. So the rate of reaction is faster in hot water. Now let's look at concentration. Here I have a 0.1 molar solution of hydrochloric acid. Here I have a 1 molar solution of hydrochloric acid. So if I took a magnesium strip and I added it to some of this acid, in which solution of acid do you expect the magnesium to disappear fastest? Okay, and that is what one would expect, that the acid would dissolve, the magnesium would dissolve more slowly in the 0.1 molar solution hydrochloric acid because it is less concentrated, and it will dissolve more quickly in the 1 molar solution of hydrochloric acid, once again because 1 molar is a stronger solution than 0.1 molar. 1 molar is more concentrated than 0.01 molar, and when we look at what happens at a particulate level, you will understand that the more concentrated an acid is, the faster, the more particles there are to collide, and therefore the faster the rate of the reaction. Now look at those two containers. They contain gas. The one is under high pressure, the second one is under low pressure. So, in which of those two containers would you expect the gases to react more quickly? Okay, again, we would expect, because this one is the high pressure one, okay, we would expect this first container, the reaction to happen a lot more quickly because the gases are under a lot more pressure than in this one. The volume here is half compared to that. So the reaction rate in the first container would be faster than the reaction rate in the second container. So this container would have the slower rate of reaction than that first container because the pressure is greater. Okay, so here I have iron nails. The other iron nails. Okay, iron shavings and iron filings. Okay, which is almost like a powder. So of those three, if I put them in water, which one would you expect to rust faster? Okay, that is correct. We will expect that the iron nails would rust slower than the iron filings. We expect this increase across. So this reaction would be slower than that one, and this one would be slower than that one. So the iron filings would react faster than the iron nails with the water and the oxygen to form rust. And that is what I mean by the state of divisibility. It is increasing from iron nails to the iron filings, and the smaller the pieces are, it means that the surface area over which the oxygen can react with the iron is increased. There are more surfaces on which the oxygen can begin to rust, and so the reaction will happen faster from iron nails being the slowest, with iron filings being the fastest. Lastly, the catalyst. In which of those two flasks will the hydrogen peroxide decompose more quickly? Let's have a look. Okay, there he's adding the hydrogen peroxide to both flasks. It will decompose over time, but the reaction happens very slowly. Now, look what happens when he starts adding some of the manganese, I think it was permanganate, into each of the flasks. Into the one flask. You can see on this flask, the gas bubbles are being produced, which shows that this reaction is happening faster than that reaction over there. So in terms of a catalyst, without a catalyst, the reaction in that flask was slower than in this flask. So a catalyst has sped up the rate of the reaction. Grade 12s, for this session I've done most of the talking. Now it's time for you to put on your thinking caps. I would like you to discuss how each of the factors we've mentioned has an impact on the rate of a chemical reaction. So until next time and next week's virtual lesson, this is the opinionated science educator from the Mamelodi campus for the PUA Saturday program. Until next time, goodbye.